Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, well, we're going to take a look at the ISO 9000 requirement for statistical process control. Because in the ISO 9000 requirement, it says use SPC where appropriate. I'm not sure where it's not appropriate. It would be much better to say don't use SPC if it's not valid, and then you have to prove that it's not valid, because SPC is always appropriate. How can you say such nonsense, especially when ISO is supposed to be the arbiter of world-class behavior? So let's take a look. The ISO 9001 SPC requirement. What do you mean, where appropriate? It's the most ridiculous statement I've ever heard. By the way, just before we carry on with this video, if you want to know more about this and other subjects, drink tea and read the paper, my latest book. Everything's in there, plus an awful lot more. So let's get to this. Where appropriate. Let's talk about why it's always appropriate. Here's the deal. You can never know what your process is doing without statistical process control. You can never know what your process is doing and make proper adjustments without statistical process control. Let me show you why. Here's your process. Here's the way that you've set it up. Here's the way your technician has set the process up. They've centered it perfectly. Unfortunately, it's not a process that's capable, but they've done their job brilliantly because they've centered it. By the way, that's as much as they can do. An operator can do no more than to center it. Okay, now, the operator needs to know that he's done a great job. He needs to know he has the process in the perfect position. Okay, so he has to, of course, take data in order to do that. Now, if he starts to extract data from there, of course, what he's not going to see, and this is important, what he's never going to see is that picture. So he doesn't get that picture. That's a representation of 50, 100, 200, 300 data points, because he doesn't see that. What does the operator see? Well, of course, what the operator sees is one data point at a time. And he has to judge from one data point whether he centered it or not. Well, how the heck does he do that? Well, the way he does it is to use some rules. He uses a control chart. What the control chart does, by the way, is it communicates this picture to him. So it actually communicates the tips of the distribution. That's what the control limits will be. A control limit. Lower control limit, upper control limit, actually tries to represent the tips of the distribution. So the control limits on this thing represent the tips of the distribution. And of course, the other data point, the other line that you put on the run chart, you also put the center line, the average on there. And then he knows what he's doing. He knows what this picture looks like. It's communicating this picture to him, because at some point he's going to get a data point which lands there. Now, normally when operators get data points that fall outside of the tolerance, what's their next behavior? Well, their next behavior is to adjust the process. Well, if he adjusts this, a process which is perfectly set, by the way, he is achieving the minimum defect rate for this process. What will he do? He'll wind this process over here. And he'll make it worse. What an SPC chart, of course, will do, it'll see this data point here. See it, whoops, not down there though. It'll see it outside the tolerance, but inside the control limit. And because it's inside the control limit, he'll keep his hands off and he'll never make this mistake. He can only do that with an SPC chart. This is always appropriate. This is always appropriate, because what's the alternative? Well, the alternative is this. Let's draw a different distribution. Now he has this situation. Okay, so now he's got defects out of this side, just the same as he had a defect out of that side. Now, would it be appropriate for him to adjust that process? Well, the answer to that is yes. But of course, he just sees a single data point. So this single data point looks identical to this single data point. Now, is it appropriate for him to adjust this process? Well, of course it is. He should adjust. He should adjust the process. That's correct. Here, he shouldn't adjust. Here, he should adjust. But what does the data point look like? It looks identical to him. How does he know how to make the right decision? He can only make a correct decision using an SPC chart. It's the only way that he can do it. By the way, the control limits. If this process was much tighter like this, if you'd centered this, let's draw this down here, just to make the point, the process would have looked like that. The control limits, by the way, would have fallen there. Not only would he adjust it for this data point, actually, he would have adjusted for that data point, even though that's inside the tolerance. That's not an indication that your process is perfectly set. You want your process to be perfectly set, don't you? Perfectly set means centered. That's what perfectly set means. You want your process to be perfectly set. You need to give him the tools to help him to do that. You need to give him the tools that gives him the signal to adjust when it's appropriate, to not adjust when it's appropriate. SPC is always appropriate, you ISO idiots. Why would you write that in best practice documentation? I don't understand. SPC will always ensure that you make the maximum amount of money from your processes. I would suggest that that tool is always appropriate. SPC, make sure you use it. And by the way, if you want to disagree with this video, I'd love to start comments in the area below this video, folks. If you can send me examples where it's not appropriate, when you're manufacturing something and you think this isn't needed to make pots of money, send me some examples. Let's find out if this is really the case. Let's start a conversation about this, and let's send that conversation to ISO. ISO, sort yourselves out. This is always appropriate, because we're always trying to make pots and pots of cash.